Okay, I want to revisit elasticity a little bit in this unit because we talked about it just briefly in Unit 1. We did some last semester, but now we got to approach it in a different way. Now, what we've already talked about is the idea that a straight line demand curve has 3 different regions, that they tend to be more elastic in the upper half, they tend to be more inelastic in the lower half at lower prices, and unelastic in the middle. Now, that's great, except how does that translate into actual behavior in the marketplace if you're a business and you're trying to decide on a pricing strategy? So, this is fun and interesting, and that's great, but we got to look at what businesses actually might do. So, let's kill this and talk about something called total revenue. Okay, so we don't need any of that right now. It's the total revenue test that we're going to use to determine how, or to what extent we have price elasticity of demand on a product. Now, total revenue meaning the money that's earned by a business, is just price times the quantity that they're actually going to sell, which is really going to depend on the demand. Okay? Now, if you are a business and you're trying to decide exactly what is the optimum pricing strategy for your product, you would want to know if you raise the price, are you going to make more money or less money? Let's say, for example, that you're Wendy's. And you used to have the medium-sized Frosty on the dollar menu. Way back in the dark ages when a medium Frosty used to cost $1. Now, it's been a long time since a Frosty cost $1, so they're going to jack the price up. Now, if they jack up the price by, say, 50 cents to $1.50, are they going to make more money or less money? So you're Wendy's and you've jacked up the price of a Frosty by 50%. And a lot of people might look at that and go, you know what, I'll just get a different size, I'll get a small. Or they'll say,
I'm going to go to McDonald's and get a McFlurry.
Yeah, exactly. So at that point, you've got potentially enough substitute products that people are just going to decide they're not going to eat there anymore. At which point, raising the price of that one product on the menu is actually going to cause a drop in how much money Wendy's is making. Now, because you're switching to substitute products and they're losing money, that says that they're dealing with something that has a very high degree of price elasticity. In other words, it's very elastic. Okay? So if you raise the price and you're making less money because your demand just goes, then it's elastic. Now, what if we're talking about a product that is very inelastic? For example, if you're talking about life-sustaining medications, cancer drugs, for example, cancer treatments. If we raise the price of life-saving cancer treatments, then does that mean people are going to stop buying them? No, it means that they still have to have pretty much exactly what they were buying before, so a higher price yields more money. That's inelastic. Okay? And you can reverse these arrows to get the opposite effects too. Decrease in price, increase total revenue, that's elastic. Okay? Decrease price, decrease total revenue, that's inelastic. I would say don't memorize them both ways because you'll get mixed up. Alright? But the easiest way to remember this is probably to look at the increases. If you increase the price and people stop buying it, elastic. If you increase the price, people are still buying it, you're making more money, that's inelastic. The other possibility, which you probably won't have to deal with, is the idea that you change the price and your total revenue is pretty much the same. Could happen. That would be the very unique the situation of something being uninelastic. But I would say these two, much more common in any question that you're going to see. The next issue that you're going to have to deal with elasticity is the idea of cross-price elasticity. So now we're looking at how does the price of one product affect the demand for the other product. Three possibilities, and these should sound pretty familiar to you because we've talked about these same products before. You could have substitutes. You could have complements.
You look lovely today. Oh, complements. My bad.
And your third possibility are goods that have nothing to do with each other, whatsoever. Unrelated. Now, the equation for this looks a little bit messy, but in terms of how it actually works, it's not that bad. And I'm going to grab my cheat sheet to make sure that I don't mess this up. All right. So, if we're looking at the elasticity of X and Y, that would be how you express the cross-price elasticity. We want to look at how the percent change in the price of one, okay, percent change in the price of Y. Actually, hang on a second. Let's do this a little bit more concisely. Percent change in the price of product Y causes a percent change in the quantity of X. Okay? I don't know if the X and Y's are backwards. Anyhow, what you need to know is price is your independent variable, quantity is your dependent variable. So if you have two products that are substitutes, such that one gets more expensive, then what happens to the quantity of the other? You're going to switch. If they are truly substitutes, then they are interchangeable products. Which means if this one goes up, then the quantity demanded of the other goes up. You have a positive divided by a positive, or a negative divided by a negative. If this goes down, the other one goes down. Your cross-price elasticity of substitutes has to be positive. Has to be. Okay, so that's our first possibility here. What about complements? Remember that complements are two things that you buy and consume together. Easiest example is battery-operated toys. You can't use the toy unless you buy the batteries to put in it. So what happens if the toy gets more expensive? You're going to buy fewer batteries. If the toy got cheaper, you buy more batteries. Positive divided by a negative, negative divided by a positive, you get a negative cross-price elasticity for two complements. And it has to do with those relationships that you already learned as determinants of demand, with goods being interchangeable or goods going together. Now, what if they're two completely unrelated goods? You know, maybe you're talking about dog leashes and false eyelashes. I would not expect those to have much of a relationship. Anyhow, two goods that have no bearing on each other whatsoever in the market. Then when you work this equation, percent change of one, quantity change of the other, you're going to get something very nearly zero. Okay? So if it's positive, they are substitutes. Negative, they are complements. Zero or almost zero, they have nothing to do with each other whatsoever.